Yeah. So good morning, students. Today we will discuss how to solve an LPP by using graphical method. So whenever a problem is given, how to solve that particular LPP into by using graphical method. We will see the first method. Okay. So I will tell you the procedure. I will explain the procedure while explaining the problem. Step by step, I will explain. So first, I will write down the first problem. So solve the following LPP by using graphical method. The problem is given like this: maximum z equal to 45x1 plus 80x2. Okay. Subject to the constraints. Write down the first constraint: 5x1 plus 20x2 less than or equal to 400. Next, second constraint: 10x1 plus 15x2 less than or equal to 450. And how many variables are there in the problem? x1, x2 greater than or equal to 0. Okay, so this is an LPP. Why this is called an LPP? Just I will explain. So the first part is called objective function. This is called objective function. That means an objective function may be maximization or minimization. This is called set of constraints. These are called set of constraints. Constraints may be less than or equal to type, or greater than or equal to type, or equal to type. Okay. So these are called decision variables or non-negative restrictions. These are called decision variables. So what do you mean by LPP? Just I am giving a definition of LPP. What is the definition of LPP? Means objective function, set of constraints. This is called set of constraints, and non-negative restrictions together is called an LPP. Okay. So LPP objective function may be maximization or minimization. If you are giving an LPP, your objective function will be either maximization type or minimization type. Constraints are either less than or equal type, or greater than or equal type, or equal type, or there is a combination of all the three. So if any, these are called constraints, and decision variables are non-negative. How many decision variables are there? Two are there. That's why x1, x2 greater than or equal to 0. So what do you mean by LPP? An LPP is nothing but an objective function, set of constraints, and non-negative restrictions together is called an LPP. Now, how to solve these LPPs? So there are four methods are there of solving LPPs. First one is graphical method. Second one is simplex method. All are simplex methods only. So ordinary simplex method, and then bigger method, and then two-phase simplex method. So these are the four methods. So first we will discuss the first method. So whenever an LPP is given, how to solve that LPP by using graphical method. So the first point is when graphical method is used. So graphical method is used only for two decision variables. That means in your problem only two decision variables are there. See here, x1, x2 are there. Only in the problem two decision variables are there, then only you can use graphical method. And then, so you will have only less than or equal type or greater than equal type constraints in your graphical method. So if you have equal type constraint, you cannot apply graphical method. So there are 2 points. When graphical method is applied, only for two decision variables. So two decision variables, x1, x2. So two decision variables are there. That means you can use graphical method. That means simple LPPs of two decision variables can be solved by using graphical method. So I will solve this LPP by using graphical method. So I have already given the procedure for graphical method. So how many steps are there in graphical method? 6 steps are there. Okay. So first I will discuss step one by one. So in graphical method, the first step number 1 is convert all your inequality constraints into equality constraints. And how many inequality constraints are there here? Inequality means less than or equal to or greater than equal. Now see here, how many less than equal type constraints are there? 2 are there. So first step in graphical method is convert all the inequalities. It may be less than equal type or it may be greater than equal type. Convert all the inequalities into equalities. That is step number 1. So in this particular method, we will discuss. There are 4 models are there. So in graphical method, first model we will discuss is objective function is maximization, constraints are less than or equal to. First model we are discussing is objective function maximization, constraints are less than or equal to. Second model we will discuss is objective function is minimization, constraints are greater than or equal to. This is the second one. Okay. Third model we will discuss is Objective function may be maximization or minimization, constraints less than or equal to or greater than equal to. Both less than equal to and greater than equal to. Both we will discuss. Both constraints. Okay. So fourth model we discuss is special cases in graphical method. Special cases in graphical method. Special cases in graphical. So total 4 models are there. So for any model, only 6 steps will be there. So we know the 6 steps already. The 6 steps is with you. Those 6 steps only we will discuss. Okay. So the first step, first model we are discussing is objective function maximization. Constraints are less than equal to C. Objective function maximization. Constraints are less than equal to. So first model we are discussing this one. So I will tell you one problem in this model, one problem in this model, one problem in this model, and special cases. 3 special cases are there. So 3 problems from 3 special cases. So total 3 plus 3, 6 models. But any problem in graphical method consists of only those 6 steps I have given. Okay. So what is the first step in graphical method? The first step is, what is the first step? Convert all the inequality constraints into equality constraints. So in this particular problem, how many inequality type constraints are there? How many inequality type constraints are there? These are the inequality type constraints. Now first convert these inequalities into equalities. Okay. So write solution. Write down the solution. Step number 1. Step number 1. Write down convert all the inequalities into equalities. Convert all the inequalities into equalities. That means inequality constraints into equality constraints. Okay. Then we get 5x1 plus 20x2 is equivalent to 400. This is equation number 1. Now I am converting inequality into equality. Next, second constraint. One more constraint is that what is that one? 10x1 plus 15x2 is equivalent to 450. 450. Equation number. Now step number 1 I have completed. What is step number 1? Convert all the inequalities, all the inequality constraints into equality constraints. So I have finished step number 1. Now see step number 2. I have given the procedure. See step number 2 now. What is step number 2 now? I have to plot these equations on the graph. Graphical method. So you have to plot these equations on the graph. If you want to plot these equations, you require points. If you have points, then only you can plot these lines on the graph. So the second step is plot the equations on the graph, as each one will be geometrically represent a straight line. Is a straight line linear equation or not? This is a linear equation. So step number 2 is nothing but plot each equation on the graph, as each one will geometrically represent a straight line. Okay. So how you have to plot? For plotting, you require the points. And the next step is you have to identify the points for the equations. How will you identify the points for these equations? Right. Step number 2. Right. Step number 2. Step number 2. Plot. Right. Step number 2. Plot each equation on the graph. Plot each equation on the graph, as each one will geometrically represent a straight line. Plot each equation on the graph, as each one will geometrically represent a straight line. Okay. So now how will you identify the points? Now I will consider equation number 1. Okay. Consider equation 1. First listen. If you understood, then you can write. Okay. Consider equation 1. So consider equation 1. This is equation number 1. In equation 1, what you have to do? Put x1 equal to 0. Put x1 equal to 0. If x1 equal to 0, what you will get from equation number 1? This implies if you put x1 equal to 0 in this equation, you will get 20x2 equal to 400. 20x2 equal to 400. That means what is the x2 value we get? x2 equal to 400 divided by 20. 400 divided by 20 means what is the value we get? 20. 400 divided by 20 means 20. Same. Again, consider. Now what you have done? Consider equation 1. Put x1 equal to 0. You are getting x2 point. Now what you have to do? Put x2 equal to 0. Put x2 equal to 0. Then you will get x1 point. Okay. So same equation. Put x2 equal to 0. Put x2 equal to 0. If x2 equal to 0 means what you will get? X2 equal to 0 means what you will get? 5x1 equal to 400. 5x1 equal to 400. 5x1 equal to 400. So what is the x1 value we get? So x1 equal to 400 divided by 5. That means what is the value? 80. Now I know the 2 points. So generally point, how will you write? X1 comma x2 is the point. Now what is the point for this one? What is the point we are getting? X1 comma x2. X1 comma x2 means what is the x1 value? X1 value is 80. Okay. X1 value is 80. X2 value is 20. You have to write in order. X1 comma x2. So what is the first point? What is the first equation point? First equation point is 80 comma 20. Why I have written 80 first? 80 means what is the x1 value? X1 value is 80. Point should be denoted as x1 comma x2. That means 80 comma 20. Now first equation is completed. The same procedure we will adopt. This same procedure we will adopt for the second equation, and we will identify the point. Okay. Now consider equation number 2. Consider equation number 2. Consider equation number 2. Equation number 2 means this is the equation. Okay. So this is the equation. Now put x1 equal to 0. The same procedure. What you order? Put x1 equal to 0. Put x1 equal to 0. In this equation, you are saying that x1 is 0. That means what you will get? 15x2 equal to 450. This implies 15x2 equal to 450. Now what is x2 value for this one? This implies x2 equal to 450 by 15. That means what is the value? 30. 30 is the x1 value, x2 value, sorry. Okay. Now same equation, what you have to now put x2 equal to 0. Put x2 equal to 0. x2 value is equal to 0. Now x2 equal to 0 means this value will be 0. That means what is the 10x1 equal to? 10x1 equal to 450. 10x1 equal to 450. That means what you will get? This implies x1 equal to 450 divided by 10. 450 divided by 10. That means what is the x1 value? X1 value is 40. Now I know the second point. What is the second point? X1 comma x2. X1 comma x2 means what is the x1 value? 45. X1 value is 45, comma x2 value is 30. So now I know both the points. Okay, now what is the second step number 2 you have written? Step number 2 is nothing but plot each equation on the graph as each one will geometrically represent a straight line. Okay, so for representing a straight line in the graph, you require a point. So how many equations are there? 2 equations are there. That means you require 2 points. So that's why I have identified the first point. What is the first point you got? 80, 20. And what is the second point you got? 45, 30. Still step number 2 is not completed. Step number 2 is nothing but you have to plot these lines on the graph. That means you require the points. I have identified the points. Now I know the points. I can draw the lines, straight lines on the graph. Okay, so that means what you have to do next step, within step number 2 only, you have to draw the graph. Graph means x-axis will be there, y-axis will be there. But in the problem he has given x1, x2. So we will take x1 axis and x2 axis. Okay. So I think all of you understood up to this one. So any problem in graphical method, step number 1 is that one, and step number 2 is like this. Okay. So now I will denote the graph. I will draw the graph now. So this is 80, 20 is the first point, and 45, 30 is the second point. Now what is the highest value in x1? 80. x1 80, 45. What is the highest value? 80. x2 20, 30. What is the highest value? 30. So scale is, you can consider 80, 80 like that. Okay, directly we consider, you can draw the graph. So that means I will draw the graph now. These are the points required. So now I will draw the graph. And you have to see the graph. So this is the graph I am drawing. Now I know the points. So these are the 2 points you have: 80, 20, and then 45, 30. So I have to draw the graph. So this is x1. This is x1 axis. Generally xy axis you will take. So I am taking x1 and x2. This is x2. X1, x2. Okay, so scale is your wish. So it is the maximum point. I will take up to 80. 10, 10 difference. I will take both x1 and x2. Generally, we will take equal scales. So that means this is the origin. This is the origin. So up to 80. Up to 80 means this is 10, 20, 10, 10 difference. 30, 40, 50, 60, 70, 80. 80 x1 First I will draw the first line. First line means this is the first point. First line point is 80, 20. 80 means x1 value. So this is x1 axis. X1 axis is this one. 80. X1 is 80. 80 means identify the x1 point. This is x1. 80 is the x1. Now second value is what is the value? 20. X2 value is 20. So 20 is x2 axis. This is x2. 20. Now I know 80, 20. This is the first line. So join these points by using scale. This is equation 1 or equation 2? Equation number 1. That is equation number 1. Next, second point. See the second point. What is your second point? 45, 30. 45 is the x1 value. This is x1 axis. 45 you have to add. 45 means midpoint. 45 means midpoint of 40 and 50. Okay. And then 30. 30 is the x2 value. So the x2 value is 30. This is x2 axis 30. Now join these points by using a scale. Why you have to use scale? Because only two constants are there, you are getting 2. Sometimes what happened is, this is a basic problem, first problem I am telling. So that's why I have taken only 2 constants. That's why you are getting only 2 lines. Sometimes in the problem 3 constants, 4 constants will be given, then you will get 4 lines. That's why I always use to join the points by using scale, which is better. Okay. So now step number 2 is complete. What is step number 2? Now see step number 2. What is step number 2? Step number 2 is nothing but plot each equation on the graph. Plot each equation on the graph, as each one will geometrically represent a straight line. These are straight lines or not? Straight lines. So step number 2 in graphical method is completed. Next step number 3. The most important steps are step number 2 and step number 3. Step number 3. Step number 3 is nothing but you have to identify the feasible region or common region. Feasible region. It is also known as common region. You have to identify. So how to identify the feasible region or common region? I have given the procedure to you. Just go through the procedure. So how to identify the feasible region I will tell you. So if the constraint is less than or equal type, only 2 types of constraints will be there in graphical method, either less than equal to or greater than equal to. Suppose if your constraint, original problem, see the original problem, already original problem is with you. So in the original problem, if the constraint is less than or equal type, you will shade below the region. Below the region like this. This is called below. This is called above region. Okay. So if the constraint is less than or equal type, you will shade below the region. Below the region. If the constraint is greater than or equal type, then you will shade the above region. Above region. Only 2 types of constraints is possible: less than or equal to and greater than equal to. Less than or equal to means suppose this is a line. Less than equal to means this is called below the region. This is called below the region. This is called above the region. Less than equal to means always you will identify the below the region. Greater than equal to means always you will identify above the region. Now see, in this problem, both the constraints are less than equal type or greater than equal type. So in this particular problem, we have given 2 constraints. Original problem. Both the constraints are less than or equal to type only. Less than equal to type only. Both the constraints are. So that means less than equal type means what you have to do? You have to shade the region below the region. Below the region is shaded. Now see, first constraint. This is the first constraint. First constraint is this one. Okay. So first constraint is less than equal type. Less than equal to means below the region. Below the region like this. Below the region like this. Because 2 parts are there. That's why I am identifying below. And second constraint. Second equation. Second equation is also less than equal type. Second constraint is also less than equal type in the problem. So second constraint is what is it? This is the second type. So below the region like this. So below the region like this. So like this. This part is common, shaded region. Okay. So both the constraints are. This is the first model I am saying. Objective function is maximization. Constraints are only less than equal type in the problem. Less than equal type means always shade the below the region. Now identify the common part and where both the lines will be there. Both the region. Common part you have to identify. What is the common part? Is this a common part or not? This is the common area. So this is not a common area. Why this is not a common area? Because first line, second line, first line starts from here onwards. So first line won't be there here. So that means this is not a common part. This is not a common part. Why this is not a common part? Because second line starts from here onwards. Second line. Okay. Second line won't be available here. Second. So this is also not a common part. So obviously, what is a common part? Both the lines will be there here. Both the lines. So this is called common part. That common part you have to identify. That common part you have to identify like this. So this is called the feasible region or common region. So what is the edges for this feasible region? O, and this edge is A, this edge is A, and this edge is B, This is not a common part, this one is a common part. So this edge is C. And what is the common part you are getting? What is the common part you are getting? O, A, B, C. O, A, B, C is the feasible region. So this is O, this is A, this edge is A, and this edge is B, and this edge is C. So that means what is the common part? O, A, B, C is the feasible region. So write step number 3. Step number 3, O, A, B, C is the feasible region. Step number 3, below the diagram you can write step number 3, here you can write step number 3, O, A, B, C is the feasible region. Is the feasible region. Now you can denote the graph like this. Step number 2 will be completed here. Step number 3 is nothing but identify the common region. So I have identified the common region. What is the common region you will get? This is the common part you have. So that means that is O, A, B, C. So O, A, B, C is the feasible region. So this is step number 3 in graphical method. Next, I think all of you understood up to this one. This is the first problem. Little bit confusion will be there. If you understood the concept, then it will be easy for further problems. So anyway, it is first problem. So I think you are able to understand this one. So common part only you have to identify. I have identified the common part. So that edges only I am considering. O, A, B, C is the feasible region. Next, step number 4. Step number 4. Step number 4. Now what is step number 4? What is step number 4 in graphical method? Step number 4 is nothing but now I know the feasible region. I know the corner points of the feasible region. Now what is this corner points you have to identify? You have to identify the corner points of the feasible region. Corner points are this is O. A point you have to identify, B point you have to identify, C point you have to identify. So that means you have to identify the corner points of the feasible region. Right? Step number 4. Identify the corner points of the feasible region. Identify the corner points of the feasible region. Identify the corner points of the feasible region. Corner points of the feasible region. Then we have what is the first corner point? O. O point, all of you know. O means what is the origin? Origin is 0, 0. So O point is 0, 0. O point is 0, 0. A point. A point we have to identify. Generally A and x-axis. This is x-axis. Generally this is x-axis. X-axis point is what is it? X-axis point is always A, 0. A, 0. That means what is yours? A value here 40, 45. Sorry. This is mid term 40, between 40 and 50. This is the midpoint. So A value is 45. So that means what is it? 45, 0. X-axis point always A, 0. Y-axis point 0, A. Already you have done in your intermediate. X-axis point is always A, 0. Y-axis point is 0, A or 0, B, whatever. Okay. Now A is completed. Next corner point is B. This is important. How you will get the B? B is the intersection of. This is the intersection point of what? Which lines? 1 and 2. And if you solve 1 and 2, you will get the B point. Right? B is the intersection of 1 and 2. B is the intersection of 1 and 2. And if you solve first equation and second equation, those are there in step number 1. See your equations in step number 1. Okay, if you solve those equations, you will get B point. You will get the B point. So I am solving those equations. What is the first equation? You have 5x1 plus 20x2 is equal to what is the equation you have? 400. 400. This is equation number 1 you got in step number 1. And the second one is 10x1 plus 15x2 is equal to what is the value? 450. 450. This is equation number 2. If you want to solve these equations, I think all of you know how to solve these equations. Either you have to make it as x1 coefficients equal or x2 coefficients equal. So I will make it as x1 coefficients equal. This is 10. You have 5 here. That means what is the first equation into 2, second equation into 1. So first equation into 2, second equation into 1. Then after that you will get 10, 10 here. Okay. So then we get what you will get. Just I will convert out. Then what you will get? 10x1 into 2 into 2 means what is it? 10x1 plus 2 into 20, 40x2 is equal to 800. second equation to 1. Second equation 1 is the same equation. You get 10x1 plus 15x2 is equivalent to 450. So how x1 coefficients will be cancelled? If you do minus 10 minus 10, then you will get 0. That means what I will do, I will put minus. I will subtract both the equations. First equation minus second equation. Then what you will get, 10x1 minus 10x1 get cancelled. This is 40 minus 15. 40 minus 15 means what is it? 25. Plus 25 will get 25x2 is equivalent to 800 minus 450. 800 minus 450 means 350. 350. So that means what is the x2 value? x2 equal to 350 divided by 25. 350 divided by 25. 350 divided by 25. That means if you do this subtraction, what you get? I think 14s. 14 5s are 70, 0s are 4, 2s are 28 plus 7 35. So 14. So now I got x2 value. X2 value. X2 value I got. So substitute in any one of these equations. Any one of these equations you will get the x1 value. So I will substitute in first equation. What is the first equation? This is the first equation you have. In this I know x2 value. What is the x2 value you got? x2 value is 14. x2 value is 14. So that means I will substitute x2 here. I will find out x1 value. Okay. So, therefore, from 1 employees, and equation 1 I am considering. What you will get? 5x1 plus 20 into x2 value. What is x2 value? You got 14. So 14. X2 value 14 you have. 14 is equivalent to 400. Is equivalent to 400. If you subtract this one, automatically you will get this one. This implies 5x1. What is this value? 28. 280 is equivalent to 400. Is equivalent to 400. Side this 280, that's it. That means what you will get? 5x1 is equivalent to 400 minus 280. 400 minus 280 means what we get? This is nothing but 120. So therefore x1 equal to, this implies x1 equal to 120 divided by 5. 120 divided by 5 is what is it? This value is 24. Now I got the B point or not? B point is nothing but always point can be written as x1 comma x2. What is x1 value? x1 value is 24. What is x2 value? x2 value is 14. And what is the B point you are getting? Therefore B point. What is the B point you are getting? 24 comma 24 comma 14. 24 comma 14. Now how many corner points are there in feasible region? O point is completed 0 comma 0. A point is completed. A point is 45 comma 0. B point is completed. Last one is C point. C point I have updated out, but you know the point value. So last one is nothing but C point, right? Last corner point is C. C at the y-axis point. So what is the y-axis point? Already you have finished. No y-axis point. What is that point? You will get 20 together. So that means C is nothing but y-axis point is 0 comma 8. That means 0 comma 20. 0 comma 20. You have the graph already. So 20 you got here. C value at the point C you have 20. Okay. So 0 comma 8. 0 comma 8 is 0 comma is 20. So now step number 4 is completed. What is step number 4? Identify the corner points of the feasible region. I have identified the corner points. What is the O point you are getting? 0 comma 0. What is the A point you are getting? 45 comma 0. What is the B point you are getting? Just now we have finished 24 comma 14. And C point you are getting is 0 comma 20. Now I got step number 4 is finished. I have identified all the corner points of the feasible region. Next, step number 5. I think all of you understood this one. Step number 5. We move to step number 5. Step number 5 is nothing but check your objective function. Identify your objective function. So step number 5. Step number 5 is nothing but identify your objective function in the problem. What is the objective function given? Given that, what is given? Given that maximum is given or minimum is given? Maximum is given. Given that maximum z equal to, what is it? What is the function given to you? 45x1 plus 80x2. This is the maximum z is given. Now how many corner points you got? How many corner points you got? O, A, B, C. So step number 5 is nothing but substitute these corner points in the objective function. Substitute these corner points in the objective function and identify the maximum value or minimum value. First model is maximum value. So that means identify the maximum value. That is step number 5. Step number 5 is nothing but identify your objective function and then substitute these corner points in the objective function and identify the maximum value. Identify the maximum value. So I am substituting. First point is ZO. What is our O point? O point is 0, 0. And x1 is 0, x2 is 0. That means what you will get 45 into 0 plus 80 into 0. Means obviously we will get 0. Okay, next Z second point ZA. What is our A point? 45, 0. And x1 is 45, x2 is 0. So 45 into 45 plus 80 into 0. You can find out this value. You have a calculator, calculator is allowed, you can identify the value. Next ZB. ZB. B point is 24, 14. 24, 14 means what is that? 45 into 24 plus 80 into 14. We can simplify that, you will get the value. And ZC, last ZC equal to 0, 20. 0, 20 and 45 into 0 plus 80 into 20. 80 into 20 means 1600. Remaining values you can identify. You can identify the values. What are the values you are getting? I think B24, 14 you are getting 2200. This you will get 2200. You can check once. And then your A point. That means what is it? 45, 0. 45, 0 you will get 2025. 2025. 2025. So these are the values you are getting. So that means identify the maximum value. Maximum value or minimum value of it. Objective function maximum, minimum, maximum. Identify the maximum value. What is the maximum value you have? 2200. And what is the answer for this particular problem? Objective function values. What is the maximum value? Is 2200. At which point? At which point? B. What is the B point? 24, 14. 24, 14. And last step. Step number 6. Step number 6. Last point. Step number 6. This is the last point. Step number 6, you got the answer. What is the answer you got? The optimum solution for this particular MPP by using graphical method is 2200 at the point B. Right? Step number 6. The optimum value to the given LPP by using graphical method. Graphical method is maximum z equal to what is the value again? 2200 at the point what is that point? At the point B 24, 14. 24, 14. So this is the solution of a graphical method. Now see the procedure. I will explain the procedure now. Now you understood the problem. So if you understood the problem, you can write the procedure very easy. So in graphical method, so what is a graphical method? So graphical method is applied only for two decision variables. A simple LPPs of two decision variables can be solved by using graphical method. So in graphical method, how many steps will be there? 6 steps will be there. 6 steps. So what is the first step? Step number 1 is nothing but convert all the inequalities into equality constraints. Convert all your inequality constraints into equality constraints. That we have done. Okay. Step number 2 and 3 is important. What is step number 2? Step number 2 is nothing but plot each equation on the graph as each one will geometrically represent a straight line. I think if you have the copy with you, the procedure copy with you, now you can see the procedure copy, you can understand better. Okay, so step number 2 is nothing but what is it? Plot each equation on the graph as each one will geometrically represent a straight line. Okay, how will you identify the graph? By identifying the points. So that's why how many equations are there in this particular problem? 2 equations are there. That means how many points will get? 2 points will get. So how will you identify the points? I have told the procedure. So and then draw the graph. After drawing the graph, step number 3. Now see step number 3. Step number 3 is nothing but you have to identify the feasible region. Feasible and a common region you have to identify. So how will you identify the feasible region? Check your constraints are less than equal type or greater than equal type. Less than equal type means below the line is shaded. Less than equal type means below the line is shaded. Greater than equal to means above the line is shaded. In this first model, both the constraints are less than equal type only in this model. Okay, so that means less than equal to means what is that? Below the line is shaded. So I have shaded below the line and I have identified the common region. What is the common part I have identified? That is called feasible region. So what is the feasible region you got? O, A, B, C. You got O, A, B, C is the feasible region. Next is step number 4. Step number 4 is that you have to identify the corner points of the feasible region. And you have to identify these corner points. The O point, A point, B point, and C point you have to identify. So I have identified O, A, B, C points. Next, step number 5 is nothing but check your objective function. What is the objective function given to you? Write down that objective function. Maximization is given, you can write maximization equal. Minimization is given, you can write minimization. So in this model, we have maximization. So I have written the maximization and I have identified ZO, ZA, ZB, ZC. Because how many causal points of the feasible region are there? 4 are there. So the 4 Z values I have identified. So now your objective function is maximization or minimization? Maximization. Go for maximum value. What is the maximum value you have? 2200. At which point you got B point. And what is your answer for this particular problem? Maximum Z equal to 2200 for at the point B. At the point B. What is the point B? 24, 40. I think you have understood the method how to solve an LPP by using graphical method. This is the first model I have discussed. What is it? Objective function is maximization. Constraints are less than or equal to time. For any problem, any graphical method, these are the only 6 steps you have to follow. Steps are same. Okay, so you have to identify different models: maximum, minimum, or combination, or special cases, or exceptional cases in graphical method. I hope all of you understood. Just go through this problem carefully. And the next class, I will tell you the next one. What is the next one? Minimization. Constraints are greater than equal to. I will tell you one problem. And after that, we will discuss objective function is maximum or minimum, mix. Okay. And then constraints are both less than equal to as well as greater than equal to. And fourth model we will discuss is exceptional cases in graphical method. That is, some special cases are there in graphical method. For any of these model, only 6 steps will be there. Those are the 6 steps just now I have explained. I think all of you understood this one. Thank you. We will end this session here.